What is going on, guys? Welcome to your 11th physics lecture, and in this lecture I want to talk to you guys about Newton's second law. So here we have Newton over here, and he's looking more and more dumb each time. But his second law says something like this: the more inertia an object has, the more force is required to accelerate that. So what the heck does that mean? Well, let's go ahead and take a look at a modern day example by looking at two objects with different amounts of inertia, aka different amounts of mass. So say we have one meatloaf, and this has a mass of 8 kilograms, and say we have a smaller meatloaf with a mass of 4 kilograms. Well, we're sitting at the table, and your mom asks you to pass them to her, aka to accelerate the meatloafs towards her in this direction. Say she's sitting over there. Well, according to Newton, if you have an object with twice the mass as another one, aka meatloaf A has twice the mass of meatloaf B, then you would need 2 times the force, or twice the force, to accelerate it at the same rate as the less massive one. So if your mom asks you to pass a meatloaf to her, you would measure each one. This one has a mass of 8, and this one has a mass of 4. And according to Newton's second law, you would figure, okay, meatloaf A takes 2 times the force to accelerate at a constant rate, or a rate equal to meatloaf B, so I'm going to choose to accelerate meatloaf B to you, or pass this one to you, because it takes less force, it's going to be easier. Make sense? Well, probably not, because you don't use physics a lot with meatloafs. So let's go ahead and take a look at the proper formula, the boring stuff. So the formula to calculate force, well, first of all, so the symbol is uppercase F, and the formula is ma. In other words, force equals mass times acceleration. Now, I know I didn't talk to you guys about the units of force yet, but a real quick, hint about what's coming in the future. The unit to measure force, we typically measure it in something called newtons, but I'm going to be saving that for the next tutorial. I'm just going to be calling it force right now. So whenever you want to calculate the force, or how much effort you need to put into something, and I shouldn't even say effort because then we get into work, and we're going to be talking about that later on, but you take the mass and you multiply it by the acceleration of something. So say that we have a bowling ball right here, put 3 holes in it, and it's just sitting there. It's going 0 meters per second, and we'll say it has, I don't know, we won't even give it a mass because we'll change it up a little bit. So we wanted to figure out the force that it would take to accelerate 2 different bowling balls that are at rest. Now the first bowling ball has a mass of 5 kilograms, and we want to accelerate it from 0 to 3 meters per second. Well, this, according to Newton's formula, force equals mass times acceleration, would equal a force of 15, and I won't even go into the units because I'm going to be talking about the units of force in the next lesson. So mass times acceleration equals 15. Now say we had another bowling ball of 8 kilograms, and we wanted to accelerate it from 0 to, I don't know, 2 meters per second. Well, what we need to do is multiply the mass of this bowling ball, which is 8, times the acceleration when you go from 0 to 2, just to simplify it, times it by the velocity, which is 2 meters per second, we would get a final force of 16. So if someone asked us to, throw some bowling balls at them, we would want to throw this one at them because, less force, it's probably a little bit easier to do. So there is your very simple explanation of Newton's second law. Again, one more time. The more inertia an object has, the greater the force needed to accelerate that. And since mass is related to inertia, we can figure out the mass of something and how fast or how much we need to accelerate it and come up with the force. So in the next tutorial, I'm going to be talking to you about the unit of force, which is newtons, and a bunch of cool stuff to go along with that. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video.